All right, we're going to solve a one variable inequality by graphing. So part A, well, how can you use a graph to solve an inequality? Part A, we have x squared minus 4 is greater than 0. So we are going to go ahead and graph y equals x squared minus 4. And we can graph y equals 0, and we'll talk about how to answer this question. So x squared minus 4 is just an x squared. There's not a number multiplied in front, so I know there's not a stretch or a compression. And this minus 4 is just translating our parabola. Remember, x squared is a parabola shape down 4 units. So I'm going to zoom in a little bit to graph this. I'm going to go down 4 units. That's where my vertex will be. Because there was no stretch or compression, it will have that 1, 3, 5 pattern. So up 1 to the right one, up 3 to the right one, and up 5 to the right one. And then I'll go ahead and just get those same points on the other side. And then we can draw in this parabola. All right, the other equation we had was y equals 0. So y equals 0 is right here on the x-axis. This is where your y equals a 0. And the question is, when does the x squared minus 4, when is that greater than that y equals 0? So if you look at our graph, we can see up here is when your function is greater than 0, and down here is when your function is less than 0. So what we care about is this part of our function up here. That's where it's greater than 0. So let's take a look at, it is hitting at -2. But remember, -2 is kind of a neutral point. So it's not greater than 0 at -2, but it's all the x values less than -2. So x is less than -2. That's when our function is greater than 0. And then we also have starting at 2 and all these x's to the right. As x gets bigger, our graph just continues to go up and stays greater than 0 right there. So, and all the x's that are greater than a +2. It's kind of like, for this particular example, we've talked about positive intervals and negative intervals. So these would be positive intervals of your graph. This would be a negative interval of this graph. But x is less than -2 and x is greater than 2 is the solution we're looking for on that one. All right, part B. A motorcycle is 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. Ooh. The car travels at a rate of 60 miles per hour. When will the car be ahead of the motorcycle? So here's kind of what they're asking us to figure out in words. When is the distance of the car going to be ahead or greater than the distance of the motorcycle? So what do we know about the car? The car is traveling at an average rate of 40 miles per hour. Let's let x represent our number of hours traveled. So we travel 40 miles in every hour, so 40 times every hour we're traveling will give us that distance. When is that distance greater than the motorcycle's distance? Well, the motorcycle is starting out 40 miles ahead of the car. So we've already got 40 miles ahead. And then we can add to it the distance. Oh, did you guys catch my mistake? This is not a, let's see if it'll let me erase it. That's not a 40. The car is traveling at 60 miles for every hour. Okay. I was about to say, there's just a lot of 40s in this equation. Okay, so then the motorcycle, back to the motorcycle, traveling already 40 miles ahead, and then they are increasing 40 miles for every hour that is traveled. So when is the car going to be further ahead than the motorcycle? So to solve this by graphing, we would write out two equations, y equals 60x and y equals 40 plus 40x. So if we graph those, we're going to get a graph that looks like this. You can see that, I'll zoom in here. So you can see that the blue line is representing the car. So it starts out, here's our distance. It starts out not as far ahead as the motorcycle, but it's going faster. So at some point it passes the motorcycle, and from here on out, it does have a greater distance than the motorcycle does. The motorcycle's distance over time is represented by this red line. So you can see we're starting at 40 miles, but we're only traveling 40 miles an hour. So we're going a little bit slower. You can see the slope of the line is not as steep. Right here, the motorcycle gets passed by the car, but it does just continue at its own pace. So where does that passing happen? Right here. It appears that the point of intersection is 2 comma 120. That's why I didn't have you guys graph this on paper, just because you don't have a graph that goes up that high. So I just thought I'd show you the graph so we could talk about it. So at this point, the car has caught up to the motorcycle. So to answer the question, and let's review what the question is, when will the car be ahead of the motorcycle? So our time at 2 hours, that's when the car passes. So the car will be ahead of the motorcycle anytime after 2 hours. And then here I just wrote that out. You guys can pause and write that in. Remember that 2 hours, that's the 2 from our ordered pair, that's the point of intersection. We were talking about time, so we were focusing on the x values here.